So I was asked to speak to you guys about our experience at York University, and we're very happy to be here. I was asked to do this about a week and a half ago or less than that, so bear with me. The title is BIM is Good Business. Many of you who are architects in the room, who are the architects in the room? Architects? Okay, there's a few of you. Okay, there should be more of you here. Design is good business. We all hear that, and that's very true. And I think it's fitting that BIM is good business as well. I think for most of us, and for us at a university, we've discovered that to be the case. I've actually forgot something, which I'm going to share with you in just a second, if you bear with me, as I search for something for you, because it's important that you understand this. So we just closed, I'm pulling something up that I want to share with you guys. We just closed a vendors of record for architects for services at the university. This is for projects in and around about $1 million. We also just closed for projects under $1 million for landscape architectural services. I don't know if there's any landscape architects in the room. If you are, I guess not. Okay. We just closed. We got 13 landscape architects who submitted the proposals. We selected 3, of which 3 are BIM capable, BIM ready. We also just received, at the same day we closed and received 50 submissions from architects, which means they all probably meet in some way or another their BIM requirements that we put in our RFP. Now, it wasn't overly, how would I say, descriptive as to what we expected them to do in BIM, but it was enough that it demonstrates to me that in the industry that I've been in Toronto after living and working in the United States for a while and coming back to Toronto, that things have changed. There's 50 smaller firms who are very much interested in working at York University who are BIM capable or prepared to work projects in BIM. As I'm looking for this, what I wanted, I can't find it very quickly, but we have a BIM working group that's made up of 16 people. It includes our risk management director, our legal department of the university, our maintenance and operations. It includes our space management, our project managers, custodial, grounds, and you name them. So there's 16 of us who meet every 2 months, and we discuss BIM at York University. We've been at this now for over a year, and it's because of the trajectory that we're on and where we want to be in a few years. And that is to have a virtual environment for our university that our grounds people can actually manage the facilities, where our designers can extract information, where we can use Maximo to extract information that's been tied back to our BIM processes. So how we got there has been rather interesting. And it's been a lot easier than you might imagine, actually. A lot easier. I think for most of us, I think it seems like a heavy-duty exercise, but it's a lot easier. I have 120 slides, so I think I told Jerry that I need about 48 minutes. But I think I'm going to do it in 28 going forward. So this is what I'm going to cover over my overall presentation, and I'll stop on a few examples of what sort of gave us the impetus, I guess the catalyst, to begin considering and thinking about BIM as a process, a protocol, technologies to help manage, design, plan, and operate our facilities at York University. So for those of you who don't know York, we're basically, our main campus is up here, downtown Toronto's here, the airport's here, our second campus is right here. We're about to build a new campus. I have to say, we're the only university in Canada who's lucky to be able to actually build a new campus for, I guess the build out is going to be the steady state 15,000 students in 10 years. So the way we imagine it, it's going to be the smartest, most technologically, digitally advanced campus in the world, as far as I'm concerned, if we can do that. And it's going to be planned, designed, constructed, and maintained and operated in BIM. That's our ultimate goal. And that's going to be somewhere up here in Markham, if anyone knows where Markham is. So some statistics. 1959, 2 campuses were roughly about 185 hectares on our main campus, 30 on our secondary campus. We have over 104 buildings, about 800 plus 1,000 square meters. We're pretty close to now about, I would say, close to almost 10 million square feet of space that we're overseeing We're the third largest university in the country and probably the largest single university campus, if you know what I mean. University of Toronto is bigger than obviously than we are, but in a single campus in a small area, there's over 52,000 people, plus or minus 7,000 faculty and staff. So it makes for an interesting place. This is how we started, with a vision. Our first president, Murray Ross, with a vision looking, we believe, is looking east with an idea of a super university, which has evolved over the years. This is the early years, and then sort of advancing forward in the 2010 award-winning projects. And I hope if there's any architects in the room who are responsible for these buildings, as an architect to another fellow architect, I apologize in advance when I say some of the things that were designed 10 years ago do not work. They do not work because they weren't integrated. There wasn't enough collaboration with facilities, and even maybe amongst yourselves between the planning, design, and construction teams. So, as we move forward, we embarked on our first competition at the university that I incorporated, and we were successful in building this facility, this renewal for our library, which now has had people from all over the world to come and see us about what we're doing. We converted, this is the ice rink for the York Lions, I guess that's what we're called, and it's got converted to state-of-the-art life sciences building. Another project for our French language campus, recently finished, our life sciences building. This is LEED silver, and I think the introduction of a capital project of a large scale where the skin and the structure and some mechanical work was done in BIM, without requesting it, by the way, without requesting it. A major renewal to our Osgoode Hall Law School. This is it. You know, when Upper Canada and Lower Canada was divided, Osgoode Hall existed, and their home is at York University. We recently went through a $50 million renewal on that particular project. Landscapes that we're doing in BIM as well. Our recent Pan Am Stadium, here's some pictures, that Infrastructure Ontario delivered with external third party a year late using BIM. I'm trying to figure that one out. So we really don't understand what happened along the process. But the changing drivers that I think made the university consider working in an integrated environment, in a collaborative environment. So just imagine we're 10,000 faculty and staff, each faculty jostling to find their place in the university, every department within this faculty is trying to find their own places within each of the various departments or faculties, and very seldom, many of them, speaking to each other. So I think if anything, BIM, or what my experience has been over the last 5 or 6 years, is that it has actually brought our university together. Our maintenance folks talk to us. Our facilities folks speak to each other. So the I in BIM, in many ways, is not information only. It's the integration that I think has come across the various projects that we work together with the various teams that we've had at the university. So this is just some examples of why we embarked on a $45 million renewal project for energy on the campus. That was the driver for us to think of in a much more collaborative, integrated way. And when you look at this diagram, and it's a Canadian diagram that shows that basically space heating uses 51% of the energy used is in space heating. So if we can reduce that through proper design, planning, operations, and maintenance, obviously we can reduce our overall cost of the university. We have an operating budget of the university close to $1 billion. And of course, maintenance doesn't get a fraction of that. So we have to do a lot with less. And how do you do that? Is by ensuring that the work that you do early is properly integrated and there's proper collaboration. We're communicating all the time. This is the stats from the 2030 challenge from the US that basically shows the distribution of potential energy use by 2030, and buildings will consume almost 50% of the energy of the United States. And I have to say that it would be very similar in Canada. It will be not not too different, I should say, because we are energy hogs. We're not like Europe or parts of Asia where we actually energy does cost. Here's another diagram that I've shown numerous times to internal executives and other people at the university as to why we should consider not the initial cost of a project, but also the overall cost of maintaining that project over a period of time. So as an architect, you know, I was always interested in making my signature and doing a beautiful job for the way the users use it. I seldom forgot that, you know, somebody had to operate and maintain it. But now I become much more aware, much more conscious when I have design teams working with us as to what they do. Why did they put the light up, you know, 15 meters above the floor that you can't get to. And there's spaces on our campus that the light bulbs haven't been changed in 8 years or 9 years. So think about that next time you're designing a building. So this shows the embodied energy over a lifetime, over 50 years. And look at the size and discrepancy from the initial embodied energy to build that facility. This is why I think you have no choice but to actually proceed to work in a much more integrated approach. The AEC industry, these are stats from the US, from owners saying this is what's happening to the architecture, engineering, and construction industry. So if you think about this, 38% of carbon emissions by buildings. They're saying that drawings, 92% of owners say that architects' drawings are insufficient. I agree. You get what you pay for. When you reduce my fees, I'm only going to get what you get, right? You can't ask me for a Cadillac and pay me like a Toyota Tercel. You just cannot do that. So I think there needs to be a balance in the way we actually manage our financial resources. So one of the things we have to do, and as an architect, I don't accept that, because I know as an architect we work very hard for owners, for clients. We do, to ensure that everything is seamless. But we are human, and probably most of these projects were never worked in an integrated and collaborative environment. So that said, if you look at some of these other numbers in terms of waste, 37% of material wasted on the construction site. We just delivered a $105 million project where we reduced very little waste because we used prefabrication techniques, because we leveraged our BIM model. I'm going to show you how we did that. So the statistics, our industry hasn't been changing as much as other industries around the world have changed. We're 15% retraction, actually, in terms of skill sets and knowledge and so on. So a traditional process means traditional results. Okay? For our engineering friends or civil engineers in the audience, I know this is not your responsibility, it's all our responsibility to ensure that these things don't happen. So, BIM at York. So this takes me forward a little bit. Why we made a business decision about 5 years ago to consider small projects, medium-sized projects, and large projects. And not all projects are done in BIM, just so you understand that. And not all projects are being maintained and operated. We're going to get there. Right now we have a trajectory, we have a route that we're taking on, and we're going to go there. These are just some of the reasons why we've decided to go into a BIM environment. And it's, the big picture. There's metrics that you can draw upon. There's information that makes us a more informed client, and that we can make decisions with regards to design, planning, and other objectives that we have as an institution. So think about that. And if I go down to this part here, and this is really the key in the end. I enjoy this part as an architect, as an urban planner, as an educator as well. But the part that I think after I've left with the design teams and the engineering teams, the information that resides at the university, it's the folks who are basically going to operate and maintain. Can that reduce maintenance? Yes, it can. If initially designed properly integrated, just think about it. Maybe you may need one less person to facilitate the operations of that one building or multiple buildings. And today, we're still working in an antiquated way. We continue to build like the pyramids were, right? From the ground up. Gravity's not going to change for us, but technology is changing. So think about that. And obviously, planning reliability. So now what we've done for our large capital projects at the university, we get everyone involved having a conversation. And what we do is we make decisions collectively as to where the appropriate building should be sited, because the proximity to the connections to the utilities and services are such that it won't cost us $10 million of the $50 million. But we do that and we test it through a virtual environment. And of course, informed design, enforced planning, enforced maintenance and operations means that we as a university can teach our students better, our researchers can do their job even better. Some other statistics regarding the advantage of working in a BIM environment: lower costs, faster delivery, improvements in exports, lower emissions, and the list goes on. Here's another one, another set of benefits to owners, right? The array of opportunities are endless, as you can see here, from high-level customization. In a university, all our facilities are customized. Notwithstanding what Alberta Infrastructure or Infrastructure Ontario may build in terms of hospitals, there's a formula. Every single building on our campus is a jewel within a larger context. So we have to ensure that we design them properly to fit within the larger context. This is what we do. This is what we should be doing. We started small. So for those owners in the room and those facility managers, consider the idea of working in a BIM environment. But start small. We started with the smallest project you can imagine. 37 35 or 37 square meters. That's all it is. For those who like Imperial, 400 square feet. 2 of these were designed, built in our office. Oops. Myself and part of my team, we designed this. We gave the model to the contractor, who in turn worked with NRB. And NRB is a company that does mobile structures, basically. They're just near Niagara Falls, Ontario. And basically, they're the ones that do all the kiosks for the gas stations, by the way. And if you go to their website, this is the featured project now on their site, not the Shell station kiosk. And I'm happy about that. So we designed it so that it can be manipulated on the respective site accordingly. We did the model ourselves, gave the model. The model was then used for fabrication in the plant, from which then they fabricated it, brought to our site in the final state like this. It came like this. I was in the plant with my designers, a few meetings we had basically at their factory, and we're in the office, we're looking at the model, we went to look at the fabrication in the plant, about 15, 20 meters away, and we can see the correlation. And the folks actually fabricating the pavilions were actually using the model for that purpose. So this was our first, I think, venture into building information modeling. It got installed in 2 different locations, and now you have someone like contemplating the world here at a beautiful place. And it dual purposes. We designed it as dual purpose, all in BIM. And we just won a first prize for innovation from the Mobile Building Institute, basically from the US, but it also covers Canada. A major interior renovation that we did, about $2.5 million, architectural, mechanical, and electrical done in BIM. A very small project, 375,000 square feet, a recruiting center for parents and potential students. This is where they can come and learn a little more about the university. And because it's in a complex 3-story volume that it had some fire separation issues, we tested it in a BIM environment. And then we gave that information to basically the design team, who in turn then obviously designed it accordingly. And this is what the outcome is. Our life sciences building, which I spoke about, and our other project that we started very early, and it was an existing facility. So we're all talking about new facilities. So this is an existing facility that's made up of a number of buildings, 5 buildings to be exact, 834,000 square feet, 5 sitting on a podium that's sitting 5 meters above the ground. So imagine the disconnect between the ground and this roof podium, which has been leaking for a while. We had $13 million worth of interior renovations underneath the roof, but we weren't going to fix the roof. So the idea came, why don't we do a major study using BIM for a space that looks like this in the summer or in the winter, that was designed 50 years ago for our climate. It wasn't even for Calgary. Just want to say that. This is for Toronto. Okay? This is how it looks, summer or winter. So we challenged the design teams who came to the table, and we invited small, medium, and large firms, international, local, and so on. And these were the 12 metrics that they had to incorporate as part of their BIM analysis of that complex. So you can see everything from space planning to sustainable strategies, energy, microclimate, stormwater management, all of it, over a 120,000 square foot roof. That's what we did. So they did this in BIM. The model was created. They looked at options, scenarios of all sorts. They developed a master plan for this area of about $250 million that my vice president almost dropped over. And he said, what do you mean? I don't have $250 million. I said, you're right, Gary, you don't. The idea is to plan for the future. If we can do an integrated design analysis of this facility, and then phase it in with a $2 million project here, a $5 million project here, and so on, we were able to do that. So this is our analysis. There was numerous options that we looked at for expanding the library and so on in this complex. We looked at the energy options as well in terms of what the scenario would be with various options. We looked at even things as shading, lighting, everything for every design option. Then we were able to say basically a proposition of each option in terms of what the initial investment would be, what the return on investment would be for the university, and so on and so on. That really sang and rang really well with our VP and others, because they recognized that it wasn't just a design or a planning exercise that sits on the shelf. It actually had information that if we change the windows in one of the buildings, the energy reduction is going to go down. And we did this using the BIM information model. And as a result, the outcomes were that we test the scenarios, we looked at future planning, we basically had metrics for landscaping, infrastructure, and so on. That was the outcome. That was information that was readily available from the model, and the information that was extracted from the model and provided to those who need to make decisions. So as a result of that, we embarked on our first project, a landscape project in BIM. This is about $1.2 million of landscaping with a $5 million renewal of the actual roof. We're actually changing the membrane and updating it. The environment that you saw before, that's what we had to deal with. Now we're going to have an environment that's going to look a bit like this. I'm going to enjoy being there, and I'm hoping the rest of the university. And I was told that 50 years ago, people would actually use it to go have their lunch there and so on. Today, they don't. So we're going to have umbrellas there, all sorts of things, after we've improved, obviously, the stormwater management issues and dealt with the membrane and the waterproofing that we had to do. So the old religious center is going to have a new look and feel using a particular material. We tested all this using our BIM model initially, and that was our first phase project. $6.5 million, of which $1.2 million is landscape. The landscape architects doing their work in a BIM environment, just so you know. And then, this is what's happening today on our major capital projects. So we have a $50 million expansion to a school of business, fully integrated BIM. That is basically mechanical, structural, electrical, architectural, interiors, civil, and landscape. So this is about, about 40 million total cost. And it's also, it's going to be LEED Platinum, it was initially LEED Platinum, it's now going to be LEED Gold. And it's approximately about 70,000 square feet of space. And this is what, it's going to be one of our main buildings, and it has this solar chimney. And so we're using some interesting passive techniques in terms of sustainability. But you can do that because you can test it in a BIM environment first before you actually build it. So this is what it's going to look like. And advancing forward, our new student center, we'll be the only university in Canada, I believe, or the second one with 2 student centers on campus. $70 million paid by the students. We planned it and conceived it in a BIM environment. So our department tested the site, built a model to test the scale, the size relative to all the buildings around it. We did a costing exercise of it. After which, it went to the students and said, okay, you guys can afford, with that kind of levy that you have, this much building, and now we're using their metrics that they have for the operations, because the students are going to be responsible for maintaining it. We're taking their basically monthly or annual cost for maintaining and operating. We're using that as the benchmark, so it's being designed to that benchmark. So as soon as the building gets switched on in 2017, 2018, they'll be able to operate it exactly at the level that they need to in order to make sure that their finances works as planned. So this is what it looks like. This is the area where all the student activity is going to be on the screen. This is what it looks like from the north. It's near Central Square, the exercise I just showed you just momentarily. Some of the interiors and the landscape design by the landscape architect, designing and integrating with the rest of the team in that environment. Okay? So this is their images. This leads me to, I think, the project that's really culminating for us as an institution, perhaps even maybe as a catalyst for discussion with other owners, other universities and colleges, hospitals, and so on in the province of Ontario and anywhere else for that matter. It's our cloud, which is actually called the Bergeron Center for Engineering Excellence. And this building is just opened, basically, just after Labor Day, 105 million, 13 million of equipment. And this was, if there was a BIM project that next year Best in BIM should win, this is it. Hint, hint. Kidding aside, you can see here. So basically the design team's disciplines that needed to use BIM through the life of the project, that's from conception to completion, right? All the way down to the quantity surveyor. So I'm regularly asking, is the quantity surveyor using the model to basically review, assess, investigate, analyze, sequencing, whatever, so they can put their numbers together properly, as opposed to the traditional way, because they had a unit cost for a building in the past that they just finished 2 months ago, and therefore they use that. I hate that. You know, the other thing what we did is, we also did an audit at every phase of completion of phase. So, schematic design, we looked at your model. DD, we looked at your model. CD, 50%, we looked at your model. You don't go past go unless we say so. That's how we approached it. And that kind of pushed the team to really think and collaborate and work together. And of course, one of the things that we did do, and we have had it for the last 4 years, is a BIM execution plan. That's really helped the design team to sort of lead them, guide them, and so on. On top of that, we've developed a supplement that helps the construction company, contractor, subtrades, to basically embed the information that's needed for the final record model for as-built purposes and for operations and maintenance. So it's not given to the design team, it's given to the construction manager, and then they use that to know exactly what we need in the model, because there's no sense in putting everything under the sun, including the last nut and bolt that goes into that building. So we use that, and we did a workshop, a return on investment with all the construction managers, some major sub-trades, our internal departments, they're going to operate the building and so on. And we spent 5 hours with a professional who's been in the business for 30 years, who happens to be part of Autodesk. And he helped facilitate the discussion about where the pinch points would be in a collaborative, integrated environment. And we discussed where the opportunities are and so on. And I don't have a diagram here, but in California, American Institute of California chapter has already done an analysis over the last 10 years where they say that there could be a savings somewhere between 5 to 10% if you work in a BIM environment for a project for a client. Okay? And that's been done and tested already in the US. And of course, for construction, these are the things that we expected the construction manager and all his team to actually consider when they work in a BIM environment. And all of this was leveraged in our project. I don't think there's one project like this around that we've actually used it in this fashion, this much. And of course, we had collaborative software, we had integrated document management, and co-location. Co-location, which leads to the following. We used integrated project delivery methodologies or principles that we embedded on top of the principles of BIM and so on, and the execution plan to basically help guide the whole process. Some of the applications that were used, as you can see here, from functional programming, building systems integration, all of this. And I think most importantly, I think this is really, BIM is an enabler, not just for those working in BIM or operating in BIM. I think it works for every client, department, and division, because I think it allows us to talk and speak to one another. When I first arrived at York University, silos everywhere. You probably experience it yourselves, even when you go and consult. That one department has certain, objectives with their information that they gave you versus someone else. So in order to avoid all that, I think BIM, it does integrate and it does collaborate. So when I spoke about IPD, these are the main elements that we basically harnessed in our project: collaboration, alliance, harnessing the talents and insights that people have, trust that they will actually share. And we basically said, in this particular project, we challenged everyone. I remember when I had the session, I said, 0 change orders. I said, 0 change orders. That's your challenge to you. And when I explained that to people, and they said, that's impossible, I said, why would it be? If we can figure everything out in advance in a virtual environment, it should not be impossible. But if we don't aspire to that, then there will be errors. So what we said is, as long as it's not caused by you. If we, as the owner, create change orders, not a problem. We'll pay for it, we'll cover it. But if we can work in an integrated environment, there should be no issues. And as an architect, having been working in an environment since 2006 in this world, where the firm I was with, 50% of our projects in 2006 was already done in BIM, collaborative BIM, and in 2008-9, there was already an integrated, 100% integrated BIM. There's no reason why we can't do it today. And obviously, it means maximizing and making things much more efficient for all of us. So, our cloud sitting on the hill. This is the site for it on our campus. Main library, central square that I spoke about there. This is what it looks like. This is images from the model itself. This is not renderings from anything else. It's from the model. This is what it looks like today. As you can see, the panels, they're still being attached today. A week ago, this is a picture from about a week ago, a little less than a week ago. This is a view from the northeast. This is what it looks like today that I took. This is the skin design based on the Penrose pattern developed by an engineer. You can do an infinite permutation of this pattern with 4 triangles. It's an amazing system, and I believe that credit is due with lots of folks have incredible things like Flynn, who's worked really hard with the construction company and so on to actually build a facility like this. And I gave him a lot of credit because they worked very closely with the construction manager to make this happen. So I'm looking at the time. Logistics. It was used throughout logistics, scheduling, all that. This is what I call the BIM command center, where basically the sub-trades would actually view the model at the beginning of the week, and then they were permitted to go on site. Without looking at the model, they weren't allowed to go onto the construction site, just so you know. So these are some images, progressions of the skin and how it happened. This is the skin being installed. The backup fabrication, which we just won for a concrete building, a steel award from the engineers, or the Canadian Engineers Association, or something like that, because it created the backup for this incredible facility. These are some images of the interior. As you can see, like literally these pictures are from last week, or late last week. And this leads me to sort of near the end. I see I have 57 minutes, but I'm going to take an extra minute or two after that to finish something for you guys. This is our model made up of approximately 80 models, 13 gigabytes if you look at the actual Revit model and all the other software that's been used. By using Navisworks, we're actually using to navigate through all that complexity. And this is the underground infrastructure. And obviously, we've been using it for as-built. And the as-built configuration, which includes even external third-party CAD fab, for example, has been incorporated. But through Navisworks, we'll be allowed to actually navigate. If I ever need to replace one of those panels, for whatever reason, we can do it. And we use it for prefabrication. Here's the skin under construction. 3D model of the shop drawings. This is how they came, how they got approved, by the way. From there, they got fabricated. Plumbing, electrical, all sorts of things got fabricated off-site. If it wasn't for BIM, there's no way we could have delivered this project planned, designed, constructed, and finished in 3 years. Just to finish things off, we've incorporated into an as-built model, basically information regarding operations and maintenance. So working with them closely, they gave us their asset management SOPs and information and codes, and we embedded that to part of a model so that they can actually manage that ongoing. Because the idea was that this, if we're going to plan it, design, and construct it, there's no reason why we not operate in that environment as well. So we decided to incorporate that. So I'm going to finish with about 3 slides. And, you know, the benefit of BIM as a business proposition for the owners and anyone else who gets involved in BIM, obviously. And I'm going to only highlight a few of these. And that's building performance and sustainability. From an owner's perspective, that's key, ongoing. You know, enhanced branding. You know, if our buildings do not perform, our students will say that to the next student, the next instructor will find a job at another institution. So it's important that we maintain and operate those buildings. And better maintenance over time, which means, you know, they look great, they perform well. Our budget for managing and performing operations and maintenance on those buildings are reduced as a result of that. And obviously, the return on investment would be some of these metrics that you see here. Risk reduction. If you can reduce somewhere between 35 and 43, isn't that great? This is why we have our risk management group at our table regarding our BIM working group. To finish things off, a few other facilities management opportunities, reliable, you know, as-built information that's maintained for perpetuity that you can extract and draw that from. And of course, there's scheduled maintenance that you can integrate and extract information from. So that's where we're headed. So we talk about the various dimensions of BIM. For us, it's the last 2, the 6th dimension, the 7th dimension. Perhaps there's an 8th dimension out there that is important for owners and clients that all of us should strive for. Thank you.